Okay, we had to rush through our last two pages of notes, our last page of notes, last two problems on Tuesday, so I just want to go over those. The reciprocal functions, how to graph those. The first thing you need to do when you see a reciprocal function is look at the denominator and make sure that it doesn't equal 0. So in this particular function 1 over x, we know that our domain is going to have to be all real numbers x such that x does not equal 0. Now for our range, that is what y can be. Y also can be anything. It can't be 0 either because there's no way to get 0. You can't put anything in for x that will give you a 0 value for y, because if you put in 0 for x, that's undefined, so you can't do that. So the range is the same as the domain. It's going to be y, all real numbers y, such that y does not equal 0. Okay? All right, once we figure out the domain and range, we have to think about what's happening to this graph in and around those two asymptotes. Now remember, an asymptote is just a line that the graph can approach, but it can never touch. And in this case, those asymptotes are the lines x equals 0 and y equals 0, because that's what x cannot be and that's what y cannot be. And those are just the axes, the x-axis and the y-axis. So we know that our graph can't touch either one of these. And then as we look at x, if x is positive, as x is going from close to the y-axis, can't touch it, but as it's getting closer to it, as you go positive with x to the right, x is getting bigger. So what's happening to this graph? If the denominator gets very big, then the fraction itself gets very small. So y is getting small when x is getting big. And we can look at a couple of points just to kind of orient ourselves as to where we're going to be. If x is 1, we know y is 1. So 1, 1 is a point on here. And then we see that if we put in 2 for x, we're going to get 1/2 for y. So as I said, it's getting tinier and tinier as you go. So this part of the graph, as x gets bigger and bigger, is approaching that axis. And it's always getting closer and closer, which I can't really display here, but it's getting closer and closer. Now, as x starts to approach the y-axis over here, as x is getting to be less and less than 1, but not 0, you're having things like if x is 1/2, then you have 1 over 1/2 for y, so at y is 2. So y is now getting bigger. So as x gets tinier and tinier, as it approaches 0 from the right side, y can get very, very huge. So y, as x is getting closer and closer to that asymptote, getting closer and closer to that y-axis, y is shooting up. All right? So we've dealt with the situation where x is positive. Now what about where x is negative? Well, when x is negative, you have kind of a mirror image of that same thing happening. It's just that now y is negative too. Also. So again, if you put in -1 for x, you're going to get -1 for y. So you're going to get this guy right here. And then exactly the same way, as x is getting bigger and bigger in absolute value, is getting further and further away off to the left, y is getting tinier and tinier because it's becoming this little bitty fraction with a giant denominator. And then the same thing is happening as x gets closer and closer to 0 from the left side now. Y is becoming a very big negative number. It's shooting down. Good grief, that's ugly. Anyway, those are supposed to be smooth curves, and that is what the graph of 1 over x looks like. So you really have to think it through, think about what's happening, what the asymptotes are, the two lines that in this graph cannot be touched, and then what's happening as x gets big, as x gets close to the asymptotes, as y gets close to the asymptote, what is happening? So this is how we have to look at these kinds of functions. All right, next I'm going to do the graph of y equals 1 over x squared.